7.1.2 Comparing Rates. By the end of the lesson, I will be able to compare speed rates with graphs and tables. Here's some vocabulary I'd like you to write down. Unit rate is a rate, or rates expressed as a quantity of one. So for example, 5 miles per hour and 2 feet per second. All right, let's get into our first example. A local news station is selecting this week's female student for Athlete of the Week. Wendy and Yoshi, sprinters on the track team, are both finalists, and they are trying to decide who is fastest based on recent race data. Wendy's times are represented in the table at the right. It also says here that Yoshi can run 70 meters in 11 seconds, which can be expressed by the rate of 70 meters per 11 seconds. So I'm going to go with Wendy first, and I'm going to use her table and the data that they collected to set up a unit rate. So I want to find out how many meters she went in 1 second. So I notice there's some blanks in the table. I don't necessarily need those right now. I'm just going to use this first. I'm just going to use this first data point. And again, I want to find out meters per 1 second. So Wendy went 30 meters per 5 seconds. When I divide 30 divided by 5, I get 6 meters per 1 second, which is the unit rate that I want to use so that I can compare how fast she goes compared to Yoshi. Now Yoshi, I could use this table that I collected because the information over here says that she went 70 meters in 11 seconds. So that means for a time of 11, she went 70 meters, which means 22 seconds, she would go 140 meters, and so on. So I can continue to fill out the data there and use that to help me, or I can just set my rate of 70 meters per 11 seconds and divide 70 divided by 11, and I get 6.4 meters per 1 second. See, now that I created a unit rate in which they're both compared with 1 second, I can see that Yoshi goes faster than Wendy does because she goes 0.4 meters more than Wendy. All right, now based off of the information I just found, which was that Wendy, her unit rate was 6 meters per 1 second, and Yoshi was 6.4 meters per 1 second. Based on those unit rates, I can tell that Yoshi covers more ground in the least amount of time. So looking at the blue line and the black line, which line is which runner? Well, if Yoshi goes faster, that means she's going to have a steeper line, which means that Yoshi is the blue line and Wendy is the black line. We know this again because the blue line is steeper, which means Yoshi is going faster and covering more ground. All right, our next example, Diane's triathlon. Now, for those of you who don't know, a triathlon is a race in which you run, swim, and bike. So the question is asking, during which segment, A, B, or C, of the race did Diane go the fastest? So fast means that she covered the most ground in the least amount of time. And we can again look at how steep the slope is of the line. When I look at A, I notice that it's not a very steep slope, and she doesn't really cover much ground. The distance is over here. She doesn't really cover much distance in that amount of time. If we look at B, she covers a lot of distance in this short amount of time. And then again, looking at C, it's a steep slope, but she covers more ground in B than she does in C. Use the graph to determine the distance traveled during each segment of the race. So let's look at A. We're paying attention to distance traveled, not time. So when I start at 0 and I go to where A ends, she covers a distance of 0.5 miles. Then I look at B. B started at a distance of 0.5 and it goes all the way up to a distance of 12.5. So if we do 12.5 minus 0.5, B covers a distance of 12 miles. Then we look at C. C started at 12.5 and it goes to a distance of 15.5. So from the beginning of C to the end of C, it's a distance of 3 miles. All right, in the last example, how much time did it take Diane to complete each segment of the race? So now we're looking at time. If we look at A, it starts at 0 and it goes all the way to this line here. If we notice that each segment goes up by 6, that means that this one's 18. So A was 18 minutes. B goes from 18 all the way to 60. So 60 minus 18 would be 42 minutes. And the last one is C, goes from 60 all the way to 90, about 93. 93 minus 60 is 33 minutes. So now that I have found how much time it takes per segment, and on the previous slide I found out the distance per segment, I can now write a rate in miles per 1 minute. So let's start with A. A, so they want miles first per over minutes. So it went, on the previous line, we found out that A was 0.5 miles per, we just found this out, 18 minutes. If I divide, I get 0.28 miles per 1 minute. All right, B. On the previous slide, we found out it was 12 miles per, and on this slide, we found 42 minutes. So we get 0.5 miles per 1 minute. And the last one, C, we found out on the previous slide that it was 3 miles. And we found on this side 33 minutes. Divide and we get 0.09 miles per 1 minute. Using this data, I can see that, and it confirms that the middle part was the fastest and that it covers the most miles per minute.